Hey, Honors Chem, Mr. Lambert here. I'm really hoping this is the last video I'm going to post on limiting reactants. Um, I think it was question 16 of the Poggle that I pushed out to you guys, asked about uh, how much excess reactant was left over, and I haven't given you any um, guidance on how to solve for that. So here's what I'm going to do. I'm going to pause my screen. I'm going to turn my computer, and I'm going to I have the problem from video number 2 right on the board still, and I'm going to make up a problem where we can figure out how many grams of excess reactant is left over. We'll talk about it conceptually, then we'll solve it. So hopefully you watched part 2 where we solved. We went from grams of reactant to grams of product. In part 1, we went from moles of reactant to moles of product. Again, here's the question. I'm going to erase this, but I want to just kind of review with you real quick. How many grams of CO, that product that they're talking about, are formed from 70 grams of SiO2 and 50 grams of carbon? These are our two reactants. We have 70 grams of this stuff, 50 grams of this stuff. We did the calculations. I'm going to leave that up for a sec. I realize it's messy, but we found out that we would run out of SiO2 first, because 70 grams of that stuff can only produce 65.3 grams of CO. And when we jump to the same product from the other reactant, 50 grams of carbon could produce more. These are theoretical calculations. Notice I put LR. I put SiO2 as the LR. So I'm going to erase this, and then we're going to talk about, wait a minute, if we use up all 70 grams of this stuff, because we know, here's the conceptual part. We know that all of this is going to be, it's going to go away. It's going to be gone when the reaction is complete. Once again, conceptually, when we want to introduce limiting reactants, you can only produce as much product as your limiting reactant allows you to. Once this is gone, the reaction's done. So what does that mean? Are we going to use any of this other reactant? Yeah, we're going to use some, but we're not going to use all. So what we're going to do is we're going to jump from our 70 grams. We're going to start with the limiting reactant, okay? You're simply going to jump from grams of reactant to grams of other reactant. Same situation here. Notice we went to product in these calculations. We're simply going to go from grams of reactant A to grams of reactant B, and the number that we come up with in grams will be how much of this stuff we use, not how much we have. I guess I'll put my marker there. This is how much we have. How much are we going to use? We know that all of this is going to go away, but we're going to use some of this. Again, here to here, grams to grams. Let's do it. All right, so I put these numbers up from just a second ago. I erased all the crazy calculations. We know that SiO2 is our limiting reactant. This is what we started with both reactants: 70.0 grams of SiO2 and 50.0 grams of carbon. Here's the question that I made up. This is not in your book, but this is going to help you figure out how many grams of excess reactant remain, and that's why I put that up there. How many grams of excess reactant remain? Well, since we know since we know SiO2 is our limiting reactant, we're going to start with that. And like I said a second ago, we're going to jump from grams of SiO2 to grams of carbon. We're going to use the mole to mole ratio. It's going to be 4 fractions in our dimensional analysis. I'll try to make it not messy, but good luck with that. Here we go. Always start with your limiting reactant. We're not jumping to any products whatsoever, because the question is, how many grams of this stuff are we going to use? We're not going to use all 50. 70.0 grams of SiO2. I know I'm writing in an upward slant, but it is what it is. Grams of O2. Hopefully you can see that and it's big enough. Grams of SiO2. I'm Said O2, I meant to say SiO2. To moles of SiO2, molar mass, and I forget from the last problem, so I'm going to look it up. I believe it's 60.08, but I'm going to double check. What do you know? I had it right. 60.08 grams per mole. That's the molar mass from the periodic table. 60.08 grams of SiO2 cancels out. Got to run out of room here. Keep in mind, we're jumping now from moles of this reactant to the other reactant. Here we go. Mole to mole ratio, piece of cake. Moles of Si, make sure you can still see that. Yep. Moles of SiO2 to moles of carbon. What's the ratio? What's the mole to mole ratio? It's a 1 to 3. 1 on the bottom, 3 on the top. Moles of SiO2 cancel out. And lastly, with just barely enough room, we're going to go from moles of carbon back into grams of carbon. Moles of C to grams of C. Let's use our periodic table to figure out the mole to mole ratio, or not the mole to mole ratio, I'm sorry, the molar mass. 1 mole of carbon is 12.01 grams. Moles of carbon cancels out. And what this does, if you do the math, again, we know that we're going to use up all 70 grams of this stuff. The question is, how many grams of carbon will we use? I'm going to put that answer right here on the bottom as I move my computer. Here comes the calculator. I'm sorry for my hand in the way. You can still see, okay, you can see everything. 70 divided by 60.08 times 3 times 12.01. And we get to 3 sig figs. We get 41.97. So we have a rounding number of a 7 there. We're going to round that up. We're going to call it 42.0. And that is to 3 sig figs. 42.0 grams of carbon. And here's what I like to write. You don't have to do this, but I like to write this. This is how much we used. We used 42 grams, 42.0 grams of carbon to make all 70.0 grams of SiO2 go away. So that's not your final answer. The question's asking how many grams of excess reactant remain. It's simple subtraction here. I want to make this bigger as I look into the camera here. I want to make sure you can all see that. We used 42.0 grams, but remember, what did we have at the beginning? We had 50.0 grams of carbon. So it's a simple subtraction. 50.0 minus 42.0. I'm out of room, but you just subtract. This is what you have. This is what you used of the excess reactant. 50.0 minus 42.0. What are we going to get? 8.00. And actually, when you're subtracting, you should just go to the digit place with the least amount of the least amount of decimal points. We're going to call it 8.0. 8.0 grams of carbon remain. That is our final answer.